Hello everyone. Today we are going to learn about frequency characteristic of power system, mainly including how generating units, transmission, grade, and load power are adjusted to achieve a balance with frequency. I am the main instructor, Liu Qingping. As we all know from electricity-related measures, power system is mainly composed of generating unit, transmission grade, and load. If the power loss in the transmission grade is regarded as part of the load, then the power-frequency relationship of the power system can be simplified as the following figure. When the frequency steady state of this system is F, the input power of the prime mover is equal to the power of the generator, which is also equal to the load power. Then, the intersection of the power frequency characteristic of the generating unit and the power frequency characteristic curve of the load is the stable operating point of the power system frequency. Next, we take the case of a generating unit and the load to analyze the static characteristic of the load and the generating unit. It is what this figure represents when the system is operating normally, the intersection of the power frequency characteristic of the generating unit and the power frequency characteristic curve of the load is 1. The point is the balance point for stable operation. Its frequency is Fn, and power is PL1. When the frequency is Fn50H, the output power of the generator and the load power are in balance. If the load in the system increases by triangle PL, when the load increases again from PL1 to PL2, then the PL1F curve is translated to the PL2F curve. Here, we analyze it separately with and without a governor, assuming that all units in the system are without governors. The input power to the units is constant at PT and equal to PL1. At this time, the system frequency will gradually decrease. The active power taken by the load will also gradually decrease, and the operating point will change from 1 to 4, and then to point 2. This case mainly relies on the load regulation effect system to similarly reach a new balance point 2. The frequency stability value of this new balance point decreases to F2, and the active power taken by the system load remains at the original value of PL1. In this case, the frequency deviation value triangle F is mainly determined by the magnitude of the load increase value triangle PL. Generally, it is quite large and causes the frequency to decrease more, which is not very practical, of course. Each generating unit is equipped with a governor. After the system load increases and the frequency begins to fall, the governor has to act to increase the input power PT of the unit. After a period of regulation, the operating point is stabilized at point 3. At the time, the power taken by the system load is PL3, which is generally less than the power required at the rated frequency PL2. The frequency is stabilized at F3. At this time, the frequency deviation triangle F is smaller than when there is no governor. Obviously, there is much better with the governor. In this case, the incremental power triangle PG of the generating unit is negative kg multiplied by triangle F, and the change in load power triangle P resulting from the frequency regulation effect of the load is KL multiplied by triangle F. The load power actually increases by triangle PL plus triangle P. The increment in the load power triangle PL is supposed to be balanced with the increment in the power of the generating unit triangle PG, which means that triangle PL is equal to triangle PG. From the derivation just now, we know that the incremental power triangle PG of the generating unit is negative kg multiplied by triangle F, and the incremental load power triangle PL is equal to triangle PL plus KL multiplied by triangle F, and these two are balanced, so we get the value of the load increase triangle PL is negative k multiplied by triangle F. Here we call K the system's power frequency characteristic coefficient or the system's unit regulation power. We can draw several conclusions from the analysis we have just done. Under the joint action of the regulation effect of the load itself, a new balance can be reached. On the one hand, the load increases, the frequency decreases, and the generating unit increases its output according to the differential regulation characteristic. On the other hand, the actual power taken by the load is also reduced because of the frequency decrease. In this lesson, we learned about how the generating unit, the transmission grade, and the load power are adjusted to achieve the balance with the frequency. That's all for today. Thank you.